I want to take a few minutes and show you some of the advantages of using Solid Edge with synchronous technology. Here we have a case where we have a pulley system, and I want to take this pulley and I want to make it 20 millimeters wider to accept a wider belt. So how you do this in Solid Edge is I would go in here and I would edit that part. You can see there it is in the context of the assembly. I'll go ahead and hide that. You can see that it has a seat for a bearing on either side. You can see there's a hole through the center for a shaft, a pattern of holes and a pattern of teeth around there. So let's make it 20 millimeters wider. So if I look over here on the left in the feature tree, you can see that this is an ordered model, meaning this is history based, one feature on top of another feature. Being that I was not the person who designed this pulley, I have to first figure out what feature I need to edit to actually make this pulley wider. You can see that those faces highlight on the very first protrusion. So I'm going to go ahead and edit that feature. You can see what it does is it rolls the model back, and this is how history-based modeling works. It rolls the model back to that particular feature. I can see there's a dimension here for the width. I'm going to change that by 20 millimeters, and then I'm going to click Finish. And I can see that now I have a problem. You can see some exclamation marks next to some features that have failed. There's been some dependencies that have been developed that we did not even anticipate. Whoever designed this part did not anticipate me making it 20 millimeters wider, and so those feature dependencies are causing me problems. And so now I've got to figure out how to fix the model. And this is the problem with history-based modeling. Very, very common problem. So I'm going to go ahead and I'm going to undo that. I'm going to go back to the original state, and I'm going to move this to the new technology that we have in Solid Edge called synchronous technology. So I move all of those features up to synchronous. Now that they're in synchronous, I no longer have those dependencies between features. Feature 1 could be clear at the bottom of the tree because, again, there is no dependency. So how you modify a part in synchronous technology is you select what you want to change. I know that I want this front face to move. I want the inside of the lip to also move with it. So I'll select that. I also want this hub to get wider. I want this part to get wider, and of course I want the seat for the bearing to move with any change that we make to the width. So I simply select those things, I select the arrow in the direction that I want to move. You can see that as I begin to drag and make this wider, that it's staying symmetric. Because of the proprietary Design Intent Manager in the upper right corner of the screen, it's maintaining symmetry for me about the base coordinate system, which is great. So all I really have to move is 10 millimeters to get 20 millimeters wider. So I no longer had to worry about what feature to edit, what sketch to edit. All I have to do is select the faces that I want to change and make the modification. Very, very quick and easy with synchronous technology. Let's go back to our assembly. And of course we can see that we have a little bit of a problem in that all of the parts are interfering with that wider pulley. It needs to accommodate the wider pulley with all of the other parts. So I'm going to go ahead and I'm going to hide that pulley to start with. And another beautiful thing about synchronous technology is we have an option to actually select faces of parts at the assembly level. So in this case I'm going to come in here and I know that I need this to get wider. I also need the bottom sheet metal part to get wider. Notice I'm only selecting one face because it is sheet metal, has a common thickness. The bearing moved correctly because it is seated inside of the pulley with an assembly relationship. However, the spacer needs to get shorter for the wider pulley. And the cutout in this girder needs to get wider. Now I'm only going to select one face because there is a coplanar face directly above it. And one of the things that it's looking for with the design intent relationships is coplanar. So it's going to find that for me. So notice I'm at the assembly level. I've selected faces on multiple parts at the assembly level. And I can click on that arrow just like I did in the pulley and begin to drag to make it wider. And because all those parts are symmetric, that's being maintained for me. And again, I only have to move 10 millimeters. So if I turn on my pulley, you can see that everything is great. We have the clearances that we need. So you can go into the parts and make changes if they are in fact synchronous parts. You can select faces directly from the assembly level and begin to modify those. at the assembly level to change them in the part. Notice that the top sheet metal part is not as wide as the bottom, but I want them to be the same. Well, I don't want to have to measure how wide those are, so we have this option for face relationships at the assembly level. I'm going to pick coplanar. We even have a little video that shows you what that means. I'm going to click on coplanar. I'm going to select one face of the sheet metal part. It recognizes it's sheet metal. Notice I want that all to come out to be coplanar with this part. And now they're the same width and I didn't have to even do any measuring. So there you've seen some of the beauty of synchronous technology, in that you can modify parts without having to worry about history, and you can modify parts at the assembly level at the same time.